Okay, hello guys. In this video, I would like to discuss about polymers. So the name polymer implies actually it derives from two words. So poly means many and mer means fragments. So this means fragments or units actually. So it means that a polymer is a molecule that contains of many repeating units. And that repeating unit is called monomer because mono means one and mer means fragment. So monomer means one fragment or one unit, while polymer, it makes a whole. So for example, these three, like three repeat units of a monomer would create a polymer. Is it only three? No, so it can actually extend indefinitely. You can draw 5, 7 or whatever, how long you can go. But this arrays or groups of monomers would actually create what is called by polymer. So polymer is a large molecule. So in order for us to create polymer, there are actually two methods, which are addition and condensation method. So let's discuss the addition method first. So if we learn organic chemistry, we know that addition typically relates to a compound that has double bond. So double bond. I would like to discuss one of the simplest addition polymer, which is ethene. So now let's try to draw ethene. Ethene is an alkene. Because it's an alkene, it has a double bond. And because it's at, so it means that it has two carbons. So now let's draw a carbon with a double bond, and then the remaining arm we fill with hydrogen like this. So this is ethene. Now if we want to make a polymer from this unit, so now this thing is the single unit, the molecule that can be arranged into a polymer. If we want to arrange this, then we have to actually open up the bond, the double bond, especially this thing. If we open up the double bond, the carbon would have extra arms so that it can bind with something else. So in order to do this, usually in polymer reaction, we often use catalyst. But in IGCSE, it's not very often that the catalyst is asked, nor is it an important information for you. The most important thing is that you know how to draw. Is that the double bond would be kind of destroyed. And then since a bond is actually, when you're holding hands, the bond is created by two people holding hands, right? So if that hold is being released, actually two people would feel the impact. So if this bond is destroyed, then both carbon would actually now have an extra arm. So would be something like this. So both carbons will be free to bind with one more thing, one or even two more things. Well, now imagine that there are actually more than one unit. So now we have also another unit that is doing similar thing. Something like this. And also another one. Something like this. So they can actually bind. So here, here, and so on. So here from a monomer, we managed to create a polymer that consists of three repeat units in this case. So what is the name for this? The name for this polymer is actually polyethene. You might ask, why do we call it ethene? Ethene, as in alkene, with a double bond. While if you see that the polymer structure does not have any double bond, well, it's because like the original material, ethene, yeah, we respect the original material. It is composed of multiple ethene, so we just add poly to it, polyethene. Actually, we can also simplify this. So in some question, we note it like this. So we draw the open arm, but we put N to symbolize that, okay, it can extend indefinitely. So normally people would draw it like this. unless it is stated in the question that please throw 2 repeat units or throw 3 repeat units. In that case, you have to be specific and throw exactly 2 or 3 repeat units. So, in order for us to throw an addition polymerization reaction properly, usually it would be something like this. So you throw the original molecule, and we need a lot of it, let's say N. And in the polymerization reaction, it will open up, so it will form something like this, N. Okay? So technically, this is the addition polymerization. It does not produce any byproduct. Technically, it's just opening of double bond and then making a way for each carbon. What if the carbon is actually more complex than that? Yeah, I can give you an example. Let's say that it has CH3 and then Cl. No. Let's say that's CH3. Okay, hydrogen and hydrogen. I think something like this. So if you see, actually, you might be familiar with this. So this is actually a similar drawing as this. So hydrogen. It's enough. Then let me put the hydrogen here. Then let me put the hydrogen 1, 2, 3, 4. Yeah, well, let's put it here. Okay. So now this is actually, wait, one more hydrogen right here. Nah, 1, 2, 3, 4. So one carbon must have 4 hydrogens. So you have to check always CH3. Okay. So actually, if you want to make this into polymer, yeah, you kind of have to know what is this first. It's actually a double bond carbon. So it's an alkene because it has 3 carbons, so it's actually a propene. Actually, both of these drawings are propene. Just on the left side, that the propene is a little bit bent, and that's okay. But here the propene is actually straight. Now the thing is that you're opening the double bond and creating an extra arm, right? So for the carbon-carbon double bond, you destroy the double bond and then you create something like this. And then you repeat, right? You repeat. So you create this hydrogen, then this carbon, then so on. It's kind of difficult to do it like in a horizontal way. It's kind of difficult for you maybe to imagine. So that's why, in order for us to make it easier, we just bend this part. So we bend it so that the carbon-carbon double bond part, it can be extended like this. Okay. So now let's work on the left part. You have a double bond here. So addition polymerization, you destroy the double bond and then you open up the carbon like this, and then whatever is bind to the carbon, yeah, it remains, no change. So it would just be something like this. Then if you want to continue drawing another repeat unit, then you can also draw something like this. This is 2 repeat units and so on. So technically, regardless of the orientation, regardless of whatever is bind to the carbon, just destroy the double bond and open up and give each carbon their own arms. Will be much easier for you. Okay, so now let's discuss about the condensation polymerization. So condensation. So condensation, hearing from the name, condense, it's a transformation from gas to liquid. You know that it's actually related to water. So indeed that condensation actually produces water molecule or H2. So in condensation reaction, maybe I would like to review something similar to you, which is esterification. If you remember that when we have carboxylic acid and alcohol, let's say that I draw an ethanol. So this thing is an ethanol. And then I draw, let's say, an ethanoic acid. I draw it like this. Double bond O and one carbon. If you remember, both of these will actually react in order to form ester. The way that they form ester is that both of these will actually combine together and release water molecule. So OH from here and one hydrogen from here. So they will be released as water. It will be free. And then the remaining will be CCOCOC. Yeah. So you can see that this part here is the part from the ethanol. Well, this part here is the part from the ethanoic acid. Okay, so I hope it's clear. So now my question is that if you are asked to extend this, then there is no way, because there are no more ways for us to extract water in order to extend this molecule. So in esterification, it's actually kind of considered to be a condensation because it produces water molecule, but it stops here. So it's not like it's a polymer, because polymer is actually a larger molecule composed of repeating single units, but this thing is just one process, so one step only. Ethanol to an ethanoic acid becomes ethyl ethanoate. For it to be called condensation, the reaction must be able to continue indefinitely. So for example here, this is why I would like to give you an example of a double-phased carboxylic acid like this and a double-phase alcohol. Let's say something like this. Yeah. So in condensation reaction, sometimes it usually involves two functional groups. So on the left side we have carboxylic acid functional group. On the right side is the alcohol functional group. So if you see that this is unit 1 and this is unit 2. So now if they want to bind, then they will bind around here, right? Now let's see. This is unit 1, this is unit 2. So they will bind here. Let's say that I remove hydrogen here and OH here, so that we have water. So one water molecule is expelled. So now how can we draw the combined molecule? It will be something like this, exactly copying the upper part, oxygen, CCOH. So this will be the combination between these two. In order for it to be a polymer, now we need to repeat this, because this is not even one repeat unit. Yeah, this is one repeat unit, but it's not open yet. So later we have to open the arms as well. So let's say that I face another unit 1 here. So now I draw again. So I just copy unit 1. Let's say something like this. And then I have unit 2 as well. Let's say something like this, okay? So this will also bind around here. So let's say that here I remove OH and here I move hydrogen. Will produce water also. And between unit 1 and unit 2 from the second part will also bind here. So let's say that I remove hydrogen here and OH here. Let's say removing one more water molecule. So you get it. Actually it will be just repeating. So this, oxygen, carbon, oxygen. So already the second part, oxygen, double bond, then oxygen, then this part. So you see here that this is the first repeat unit and this is the second repeat unit. But this is not open arm. How can we make it an open arm? So let's say that here the oxygen is always the bind that combines different units. So now in order for us to make it open arm, let's remove the hydrogen so that the oxygen will have a free arm for us to draw something like this. So remove the hydrogen, then we get this thing. because the hydrogen is actually taking up one of the oxygen's arm. So carbon have 4 arms, while oxygen has 2 arms in this case. So if your oxygen still bind to a hydrogen and something like this, well, you cannot extend the arm of the oxygen, right? Something like this, you cannot extend the arm of your oxygen. So in order to draw it, and it has like an open-ended end, you kind of have to remove the hydrogen and then repeat it with brackets. So in this case, we have 2 repeat units actually. So repeat unit 1 and repeat unit 2. While in this case, we are expelling few water molecules. So if you see that here is unit 1, then unit 2, then unit 1 again, then unit 2, then unit 1 again, and so on. So 1, 2, 1, 2, 1, 2, repeating indefinitely. So see the difference between condensation and addition. For addition, actually, it's just 1 unit typically with double bond repeating, while for condensation, it relates to 2 functional groups, and then you expel water molecule from the combination of this. And if you see this is actually a little bit similar to the bond that we made here in ethanol and ethanoic acid, C double bond O and O. So this bond here, C double bond O and O, C double bond O and O, you see that this is the backbone of this. This is the backbone. See? This is always the connecting part. Then O, then supposedly double bond again. So if your polymer bond is actually composed because of carboxylic acid and alcohol functional group, it's called an ester bond. Ester bond. Or ester linkage. This is ester linkage. Do we have another variation? Yes, we do. So let's say that I have NH2. So this is another variation that can also appear. NH2. And then carbon, let's say. And then NH2. Then I also have, let's say, dialcohol. So alcohol on 2 sides, like this. This is just an example. So can they also create a polymer? The answer is yes. And if you can see that they will for sure combine around here. Now you need to release water molecule. So probably we take 1 hydrogen from here and 1 OH from here. So don't take all the hydrogen from the left part. Yeah, it's kind of nasty. So they will form something like this. Yeah. So this is 1 repeat unit. Let's see. Let's draw 1 repeat unit. And then the nitrogen will directly bond to the carbon and OH. Okay. If you want to draw more, then you need to face another unit 1 to the end of unit 2. So let's say that you have now another NH2, something like this. And you have another, let's say, alcohol. So here for sure you will bind here. You take the OH and you take the hydrogen, then you bind here. Then here also you take the hydrogen, you take the OH. Then you expel water. Water here, water here. So now let's draw everything. Becomes NH, H, CC, NH. And the nitrogen directly bind to carbon. And the carbon directly bind to nitrogen. Another carbon, nitrogen, hydrogen, then carbon, carbon, OH. So you see that here, it's actually until here is the first repeat unit, then this thing is the second repeat unit. But this is still not open-ended, so we can indeed make it open-ended. How? If you see that the nitrogen always lose 1 hydrogen, so in this case, we remove 1 hydrogen, we remove, well, this part I think the OH always remove, yeah. So always the connecting part is NH. Is NH if you see. The connecting part is always NH then C. NH then C. NH then C. NH then C. Okay? So in this part, we can suspect that it will be something like this. Yeah. Here it is. So this bond between NH and C, actually it's called the amide linkage. So we have two versions. The first one is ester linkage and the second one is amide linkage, depending on the functional group that the polymer bonds are composed. So you see that I was having like a quite difficult time drawing because there can be like many things in between. But if you see the carbon in the middle, they don't matter that much. But the thing that matters actually the functional group in at the edge of the molecule, right? So in order to simplify things, sometimes the question will only just symbolizes something like this. So let's say black box, pine width, white box, for example, something like this. So this thing is just a simplification of maybe something like this. Yeah, this is exaggerating, but maybe something like this. And then OH, then maybe C, 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 or maybe there are multiple branches. Yeah. So it's super lengthy and exhausting to draw all of this, right? So we just replace with black box sometimes. Then this white box, maybe replacing something like this. But we still draw the functional group so that they will be intact, because they will be the connecting linkages between polymers, between monomers. So if you are asked to draw, let's say, a polymer between these two, then you can just draw, for example, something like the oxygen loses hydrogen, C double bond O, then black box, then C double bond O, O, then white box, O, then I think C double bond O, black box, C double bond O, and then oxygen, because oxygen is the connecting part, and so on. So this is exactly 2 repeat units. It's very easy for us also to follow, because you see here, one black box, one white box, then one black box, one white box, and so on. So one unit, unit 1, unit 2, unit 1, unit 2, and so on. So these boxes can simplify our process of drawing. So these are the only important things that you know, for you to know how to draw polymers. There are indeed some characteristics of polymers. For example, like the condensation polymer, typically they are more stable or more temperature resistant, but we'll discuss that for another time. So I hope this video helps. Thank you and good luck.